At 8:32 a.m. on May 18th, 1980, they get their answer.
We are directly above Mount Saint Helens now, and there is no question that the volcanic activity has started.
Scientists have made an exciting discovery on the seafloor along the Cascadia subduction zone.
That's the same zone that could someday give Western Washington the big one, a 9.0 earthquake.
Shortly after the eruption, he saw bolts of lightning hitting the ground 1 per minute. So that was a pretty interesting development there.
Some people were describing that lightning and in the belief that it was fire coming out of the mountain. We're expressing it in those terms, but later it was confirmed that that really was lightning that was creating those flashes inside.
Beneath the calm waters of the Pacific, a hidden drama is unfolding, and it could change everything. A mysterious leak of volcanic gases near Mount Saint Helens has scientists scrambling for answers.
Researchers have named it Pythia's Oasis. They believe the water is coming nearly 3 miles from under the seafloor near the Cascadia subduction zone.
Could this be the first sign of a catastrophic chain reaction that could trigger earthquakes, eruptions, and even tsunamis?
The Cascadia subduction zone will eventually erupt into the biggest earthquake in modern history, and with it will come a level of disaster that the United States has never before experienced.
Buildings will collapse, burying thousands in rubble. Fires will break out, devastating entire city blocks.
As the ocean floor trembles, marine life faces a rapidly changing environment, leaving the Pacific Northwest in a precarious position. With the region's fate hanging in the balance, the question remains, what happens when nature's raw power collides with fragile ecosystems? Is this the start of something far more devastating than anyone imagined? A volcanic surprise beneath the waves. Mount Saint Helens, that temperamental titan of the Pacific Northwest, has long been infamous for its explosive antics. Nestled within the Cascadia subduction zone, this fiery peak is constantly under the watchful eyes of scientists. The zone itself is a high-stakes arena where the Juan de Fuca and North American plates engage in a slow-motion clash, grinding together in a colossal subterranean standoff. This geological tug-of-war fuels earthquakes and volcanic eruptions, making it a hotspot for seismic drama. To keep tabs on this ticking time bomb, experts have armed Mount Saint Helens and its surrounding volcanoes with cutting-edge monitoring equipment. Yet, while attention remained fixed on the mountains, a stunning twist emerged from the depths of the Pacific Ocean. During what seemed like a routine seafloor mapping mission, scientists stumbled upon something extraordinary. A strange leak oozing mysterious fluids from the ocean floor, alarmingly close to the infamous volcano. This unforeseen discovery has thrown a curveball into their understanding, raising urgent questions about the region's future. The leak first made itself known through odd thermal readings from ocean floor scans. Initially dismissed as just another hydrothermal vent, a common sight near tectonic hotspots, the situation quickly escalated when closer inspection revealed something far more sinister. This wasn't your typical hot water spewing from Earth's mantle. Instead, the fluid was a volatile mix of methane, carbon dioxide, and other gases often linked to volcanic activity. Even more alarming, the chemical makeup pointed to a direct line to Mount Saint Helens's magma chambers. This was more than just an oddity. It was a flashing red alert. Such leaks often act as safety valves for subterranean magma, releasing pressure bit by bit. But there's a catch. If the pressure exceeds the system's limits, the consequences could be catastrophic, potentially triggering seismic activity or even volcanic eruptions. The leak's proximity to the Cascadia subduction zone, notorious for generating megathrust earthquakes, only amplifies the threat. These quakes, capable of reaching magnitudes of 9 or more, have the potential to devastate entire regions. The existence of this leak near a major fault line significantly heightens the seismic risks. Adding to the concern is the nature of the fluid itself, particularly its greenhouse gas content. Methane and carbon dioxide, both potent climate change accelerants, are escaping into the ocean. Although current emissions from this leak are minuscule compared to global levels, it's like spotting a crack in a dam. Small now, but with the potential to worsen dramatically. Methane especially is a formidable player in global warming, with heat-trapping capabilities far surpassing carbon dioxide. A large-scale methane release from this undersea source could disrupt the already precarious balance of Earth's climate system. Scientists are now in a race against time to determine whether this is an isolated incident or part of a larger hidden network beneath the seafloor. History offers a cautionary tale with methane hydrates, methane trapped in icy formations under the ocean bed. These hydrates remain stable under specific conditions, but a slight nudge like rising temperatures or shifting pressures can cause them to disintegrate, releasing vast quantities of methane. The current leak seems linked to an enormous reservoir of methane lurking beneath the seafloor. Continued warming, whether from volcanic activity or climate change, could destabilize these hydrates, triggering a feedback loop of escalating warming and methane emissions. The fluid's composition, rich in greenhouse gases like methane, adds another layer of urgency. Methane is a potent greenhouse gas, significantly more effective at trapping heat than carbon dioxide. While current emissions from this leak are small compared to global levels, the potential for escalation is worrying. The seafloor houses vast reserves of methane hydrates, methane trapped in icy formations. Disturbances from rising temperatures or shifting pressures could destabilize these hydrates, releasing large quantities of methane and amplifying global warming. Indigenous communities who have inhabited the Pacific Northwest for centuries bring valuable perspectives to this unfolding situation. Their oral histories and traditional knowledge provide crucial insights into past geological events, complementing scientific data. Today, many indigenous groups are actively involved in monitoring and response efforts, advocating for their voices to be included in decision-making processes regarding land and environmental management. With Mount Saint Helens already showing signs of unrest, this underwater anomaly adds a dangerous new dimension to an already volatile situation. The pressing question now is, what could this leak set off? Are we looking at the potential for a catastrophic chain reaction involving earthquakes, eruptions, and even tsunamis? Is the Pacific Northwest, with all its beauty and mystery, sitting atop a geological powder keg ready to blow? The mystery of Pythia's oasis. Beneath the tranquil waters of the Pacific Northwest coast lies the Cascadia subduction zone, a 960-kilometer fault where the Juan de Fuca plate converges with the North American plate. This geological interface has a notorious reputation for generating colossal earthquakes and tsunamis, with the last major event occurring in 1700. Recent discoveries, however, have unveiled a new source of concern, a peculiar leak on the ocean floor, ominously named Pythia's Oasis. Pythia's Oasis, located off the coast of Central Oregon, is emitting warm, chemically distinct fluids from the seafloor. This phenomenon is unprecedented in the region and has captured the attention of geologists and seismologists alike. The fluid seepage is believed to originate from the subduction zone itself, potentially acting as a lubricant between the converging tectonic plates. The implications of this leak are profound, suggesting that the Cascadia subduction zone may be more susceptible to slipping, thereby increasing the likelihood of seismic activity. The presence of this leak has raised alarms about unpredictable magma movement beneath the Earth's crust. Traditionally, volcanic activity in the Cascade Range, which includes peaks like Mount Saint Helens and Mount Rainier, has been closely monitored for signs of impending eruptions. However, the fluid emissions at Pythia's Oasis indicate that magma dynamics may be more erratic than previously understood. This unpredictability could lead to volcanic eruptions not only at well-known sites like Mount Saint Helens, but also at other, less monitored locations across the Cascade Range. While officials have publicly downplayed the immediate danger posed by Pythia's Oasis, internal communications suggest a heightened sense of urgency. Emergency management teams are discreetly updating evacuation plans and conducting readiness drills in anticipation of potential seismic or volcanic events. The memory of the 1980 eruption of Mount Saint Helens, which resulted in 57 deaths and widespread devastation, looms large. Given the significant increase in population and infrastructure in the Pacific Northwest since then, the potential for loss of life and property damage is even greater today. The proximity of Pythia's Oasis to the Cascadia subduction zone is particularly concerning. The Cascadia subduction zone is capable of producing megathrust earthquakes with magnitudes exceeding 9.0, events that can unleash catastrophic tsunamis and cause widespread destruction. The fluid leak's location suggests it could be influencing the stability of the subduction zone, potentially triggering such a megathrust earthquake. The possibility of a big one has long been a topic of concern for residents and authorities in the region, and this new development adds a disconcerting variable to the equation. What makes Pythia's oasis even more unsettling is its apparent growth. Reports indicate that the leak is increasing in size and intensity, signaling escalating instability deep beneath the ocean floor. This expansion could correlate with rising pressures within the Earth's crust, heightening the risk of seismic or volcanic activity. The dynamic nature of this leak underscores the challenges scientists face in predicting geological events in such a complex and volatile environment. In response to these developments, scientists are deploying advanced monitoring technologies to study Pythia's oasis. Underwater drones, seismic sensors, and chemical analysis tools are being utilized to gather data on the leak's composition, flow rate, and potential impact on the surrounding geology. By understanding the nuances of this fluid emission, researchers hope to unravel the connection between Pythia's oasis and the broader geological processes at play in the Cascadia subduction zone. This research is crucial for refining predictive models and enhancing preparedness strategies for the region. The discovery of Pythia's oasis serves as a stark reminder of the dynamic and often unpredictable nature of Earth's geology. The Pacific Northwest, with its picturesque landscapes and vibrant communities, sits atop a complex and active tectonic boundary. While the beauty of the region is undeniable, so too are the geological risks that accompany it. The growing instability signaled by Pythia's oasis underscores the importance of vigilance, preparedness, and continued scientific inquiry. For now, all eyes are on Pythia's oasis. Will this strange leak give us the clues we need to prevent disaster? Or is it simply the first sign of something far more dangerous to come? One thing's for sure, the residents of the Pacific Northwest are living on the edge of something much bigger than themselves. As scientists race to decode the mysteries of this underwater enigma, the world holds its breath, waiting to see what happens next. Risks of Cascadia subduction zone activity. The Cascadia subduction zone, where the Juan de Fuca Plate meets the North American Plate, poses significant economic risks to the Pacific Northwest. A major earthquake along this fault could disrupt key industries such as shipping, fishing, tourism, and infrastructure, leading to substantial economic losses. The Pacific Northwest economy relies heavily on maritime trade, with major ports like Seattle, Tacoma, and Vancouver facilitating significant trade. A large-scale earthquake or tsunami could severely damage these ports, disrupting supply chains and causing delays that ripple through the global economy. The U.S. Geological Survey and FEMA estimate that earthquake damage costs the United States $14.7 billion annually, a 140% increase over the previous estimate of $6.1 billion per year from 2017. The region's fishing industry, worth billions of dollars, depends on the stability of its waters. If underwater ecosystems were damaged or made inaccessible due to seismic events, local fishermen could lose their livelihoods, while commercial fisheries could suffer massive losses. The fishing industry, worth billions of dollars, depends on the stability of these waters. Any disruption in the food chain could result in economic turmoil, especially for coastal communities that rely heavily on this resource. Tourism, another major economic pillar, is also at risk. The Pacific Northwest draws millions of visitors each year to its natural attractions, national parks, and vibrant cities. Earthquakes or volcanic activity could devastate popular tourist destinations, as well as infrastructure like roads, bridges, and hotels. If such disruptions were to occur, tourism would plummet, leading to immediate financial losses and a prolonged recovery period. Resorts and local businesses dependent on the steady flow of tourists could find themselves struggling to stay afloat, impacting everything from hotel staff to local artisans and guides. Beyond the immediate effects, the costs of monitoring, mitigation, and disaster relief would be astronomical. Governments and private sectors would have to allocate significant resources to create early warning systems, improve infrastructure resilience, and develop technologies that monitor seismic activity. Federal and provincial governments would shoulder much of the financial burden, but the costs would eventually trickle down to local communities and taxpayers. The strain on public funds could be exacerbated by insurance companies raising premiums in response to the heightened risk, placing an additional financial burden on homeowners and businesses in the affected areas. Local governments would also face the hefty price of disaster relief and rebuilding efforts, often requiring years of recovery to restore normalcy. The shared responsibility between the U.S. and Canada for managing risks associated with the Cascadia subduction zone presents both opportunities and challenges. The zone crosses national borders, making it a mutual concern for both countries. Cooperation on seismic monitoring, research, and disaster response would be crucial for minimizing the potential damage. Joint efforts could help ensure that both nations are prepared for a major event, including implementing infrastructure improvements and building resilience in local economies. However, the shared responsibility could also lead to tensions. Differences in policy priorities, funding, and disaster response approaches could create friction, especially if one country is perceived to be more prepared than the other. The potential impact on national security further complicates matters. Critical infrastructure, including military installations on both sides of the border, could be disrupted or destroyed in the event of a significant geological event. The U.S. West Coast is home to several important military bases, and any damage to these facilities would have serious implications for national defense. Additionally, both countries would need to address how such an event could affect their ability to respond to potential security threats, whether from natural disasters or geopolitical tensions. The infrastructure that supports both civilian and military operations would need to be prioritized in any risk mitigation strategies. Ethically, the question of how to intervene in natural processes raises significant dilemmas. Should humans intervene to prevent or mitigate the effects of natural disasters, even if the consequences of such actions are uncertain? Geological systems are incredibly complex, and any attempt to manipulate them could lead to unintended consequences. For example, trying to divert seismic activity or prevent volcanic eruptions might result in more severe, unpredictable events down the road. The ethical considerations of such interventions are fraught with uncertainty, as the long-term consequences could be far worse than the disaster they are intended to prevent. As such, any decision to manipulate the geological system must be weighed carefully, considering not just the immediate benefits, but also the potential risks of disrupting natural processes. Emerging technologies offer hope in better understanding and predicting geological activity. Advancements in seismic monitoring, underwater imaging, and artificial intelligence provide opportunities to make more accurate predictions, potentially giving communities a better chance to prepare for disasters. AI in particular can analyze vast amounts of data and identify patterns that might go unnoticed by human researchers, improving disaster preparedness. However, with AI comes the challenge of ensuring its predictions are reliable and accurate. The risk of false positives or missed events could undermine public trust in these technologies, making it important for researchers to refine their systems and continually test their models to minimize errors. Despite the uncertainty and the challenges involved in studying and mitigating geological risks, the need for action is clear. The Cascadia subduction zone presents an ongoing threat, not only to the Pacific Northwest, but to the broader global community, given its potential to affect shipping, fisheries, and tourism. The shared responsibility between the U.S. and Canada in managing these risks requires collaboration, but it also brings challenges that could strain relations, especially if one country is seen as less prepared. The cost of monitoring, responding to, and recovering from potential disasters will be high, placing a significant burden on both public and private sectors. The economic, geopolitical, and ethical considerations surrounding the Cascadia subduction zone are complex and far-reaching. The region's vulnerability to major seismic activity presents significant risks to industries like shipping, fishing, and tourism, with long-term economic consequences for local communities. The financial burden of monitoring, mitigation, and disaster relief will likely fall on both governments and private sectors, while international collaboration between the U.S. and Canada is crucial to managing the risks. The ethical dilemmas of intervening in natural processes must be approached with caution, given the potential for unintended consequences. The question of whether or not to manipulate geological systems raises concerns about the long-term risks in the balance between human intervention and natural forces. While there are potential benefits to controlling or mitigating seismic activity, the uncertainty of outcomes means that any action must be carefully considered. Ultimately, preparing for geological events like those from the Cascadia subduction zone is a matter of balancing risk, resources, and technological innovation. The potential for catastrophic consequences demands careful planning, but the question remains whether human intervention can truly prevent or mitigate the worst outcomes. As technology advances, we may come closer to answering that question, but for now, the Pacific Northwest remains at risk, and both immediate and long-term strategies will be crucial for safeguarding its economy and communities. And while this is all a great threat to us, humanity is not the only thing being affected by the geological activity in the Pacific Northwest. As seismic disruptions ripple through the region, the ocean's delicate ecosystems are facing an unprecedented challenge. The shifting tectonic plates and increased volcanic activity are beginning to alter underwater environments in ways never seen before. Marine ecosystems facing new challenges. Life on Earth's edge, particularly in our oceans, has always been a complex and finely balanced system. Marine ecosystems have always been adept at adapting to changes. But what happens when the environment shifts in ways they've never encountered before? As new threats emerge, such as the mysterious leak off the Pacific Northwest seafloor, the delicate equilibrium faces unprecedented challenges. This leak, spewing methane, carbon dioxide, and other volcanic gases into the ocean, poses significant questions about how marine ecosystems are adapting to this altered environment. Marine life thrives in a delicate dance with its environment, and sudden changes can ripple through the ecosystem with profound effects. Specific species are more vulnerable than others, particularly those sensitive to changes in temperature and water chemistry. For example, plankton, the foundation of the marine food web, can be highly susceptible to even slight shifts in water conditions. Changes in plankton populations can cascade up the food chain, impacting fish, seabirds, and larger marine mammals. Marine creatures are exhibiting remarkable adaptations and resilience in the face of these changes. Some species, such as certain types of deep-sea bacteria, have evolved to thrive in extreme environments, including areas rich in volcanic gases. These organisms can metabolize methane and other compounds, effectively using them as energy sources. This not only helps them survive, but also plays a role in mitigating the impact of the leak by reducing the amount of methane released into the atmosphere. However, not all marine life can adapt so readily. Corals, which are highly sensitive to temperature and acidity changes, face severe threats. The leak's alteration of water chemistry can lead to ocean acidification, which weakens coral skeletons and disrupts their symbiotic relationships with algae. This, in turn, affects the countless species that depend on coral reefs for shelter and food. The long-term consequences of these changes are troubling. As species struggle to adapt, the intricate balance of the food web is at risk. A decline in one species can have cascading effects, leading to reduced biodiversity and compromised ecosystem health. This can affect everything from nutrient cycles to the overall productivity of the ocean, impacting not just marine life, but also human industries such as fishing and tourism. Scientists are working tirelessly to understand these changes and the resilience of marine life. Using advanced monitoring technology, such as autonomous underwater vehicles and remote sensing, researchers are collecting data on temperature fluctuations, chemical composition, and biological responses. These studies have revealed that some ecosystems possess surprising resilience, bouncing back from disturbances faster than expected. However, the adaptability has limits, especially when changes occur rapidly or exceed historical norms. One example of ongoing research is the study of methane seeps, areas where methane naturally escapes from the seafloor. These seeps are used as analogs to understand how marine ecosystems might respond to the current leak. Findings suggest that while some species can adapt or even flourish, others face heightened risks, potentially leading to shifts in community composition and function. The implications of this research extend beyond the immediate region. Understanding how marine ecosystems respond to these stressors helps predict the potential impacts of similar events elsewhere and informs conservation and mitigation strategies. It underscores the importance of protecting marine environments and the need for international cooperation to address the underlying causes of these changes, such as climate change and ocean acidification. As the story of the Pacific Northwest leak unfolds, it serves as a stark reminder of the interconnectedness of Earth's systems. The resilience of marine ecosystems offers hope, but it also highlights the urgent need to address the human activities contributing to these changes. Only through concerted effort can we ensure the health and stability of our oceans, which are vital not just to marine life, but to the entire planet's well-being. So what lies ahead for the Pacific Northwest? Will Mount Saint Helens reawaken with a fury? Will the ocean floor unleash its hidden wrath? How will the intricate marine life, from the smallest plankton to the largest whales, cope with these dramatic shifts in their environment? And how will this impact the delicate balance of our planet? The answers lie hidden beneath the waves, in the heart of the earth, and in the hands of those who dare to explore the unknown. What do you think will happen? Share your thoughts and theories in the comments below. And don't forget to subscribe for more earth-shattering discoveries. Thanks for watching.